UML sequence diagrams can be very handy as a high-level design notation. Let's build up the pieces of a sequence diagram so you can see how they work. Each sequence diagram has a set of objects at the top of the diagram. Each object might be a component in the system or an instance of a class of objects, and so on. The objects have the ability to perform computation and communicate with other objects via messaging, subroutine calls, sending data, what have you. Each object has a timeline descending from top to bottom. When reading this diagram, time progresses from top to bottom along the dotted lines. The arcs are interactions between objects. An arrow that goes from one object to another indicates that the first object is communicated with the second object, and the position of the arrow vertically tells you when that happens. Generally, the timeline is not to scale, but rather all that really matters is which arrowhead happens before which arrow tail, implying that there's a dependency. Each sequence diagram shows one scenario, which we'll get to in a moment. There are optional ovals on the timelines. Ovals at the top are typically preconditions. What a precondition means is the following has to be true for this sequence diagram to apply. If it's not true, it simply means you need to go find a different sequence diagram that has all the preconditions satisfied so you know what's supposed to happen. Ovals in the middle are typically side effects. So there might be event 1 and event 2 and event 3, and event 3 causes a side effect in the far right object, where a side effect is a variable assignment producing an output to the real world, and so on. Ovals at the bottom are postconditions. Those are properties that are true at the completion of the sequence diagram. Overall, a sequence diagram is a partial behavioral description for the interaction among a set of objects. There are specific objects that participate, the rest you leave out of the diagram, and if the preconditions are all satisfied, some events occur, some side effects may happen, and at the end, the system has gone from the preconditioned state to the postconditioned state. What happens next? The system finds a different sequence diagram that now has its preconditions satisfied and executes accordingly. In general, the operation of a system is a set of invocations of sequence diagrams that have their preconditions met. If you have the set of all sequence diagrams designed for a system, then that is the behavioral description of how the system behaves overall, with each sequence diagram representing a piece of that behavior.